is a good particle motion problem. It's starting out by asking me to find the velocity function and the acceleration function, which shouldn't be too hard because it's just the derivative and then the second derivative. I need to find the times when the particle changes directions, which is going to be possibly where velocity equals 0. When velocity equals 0, I know I've at least stopped, and I have to stop if I'm going to change directions. But it could be a pause. It's not necessarily a change in direction. I could just be pausing and continuing in the same direction. But we'll find that out. And that's going to tell me when is the particle moving left and when is the particle moving right. And then I need to find, well, it says when is the acceleration 0, but I need to find that out in order to find the intervals of time when the particle is slowing down or speeding up. Because if acceleration is in the same direction as velocity, I'm speeding up. If acceleration is in the opposite direction of velocity, I'm slowing down. For example, if I'm driving a car at 60 miles an hour, my velocity is 60 miles an hour, and I step on the brakes, my acceleration is now in the opposite direction of my velocity. I am slowing down. If instead I'm driving 60 miles an hour and I step on the gas and I accelerate, my acceleration is in the same direction as my velocity and I'm speeding up. So we'll work through these right now. So I've written my derivatives here, and I'm just going to take a minute or so and show you how I check them on Desmos. So what I did was I wrote in my S of t, and then I wrote in what I got for my first derivative, and I wrote in what I got for my second derivative. Position, velocity, acceleration. And what I'm going to do, and I see that here's my graph. First thing I'm going to do is I'm going to check my settings. So I know that I'm looking for, I'm not looking for negative time, I'm only looking for positive time. And I know I don't need to go out to infinity or really big number, but I'm going to reset my x-axis. I'm going to set it at like -1, so I have a little bit of space next to the 0. And I'm going to set it as far as, let's say 20 seconds or 20 time. I'm doing that just because I kind of have a sense of what this problem is looking for in terms of x values. And because also when I look at after having done that, I can see that, well, my orange graph, which is my position function, well, it's a negative position function, so it's going to have up, down, end behavior, and I can see that I'm kind of coming from the up, somewhere down here and on the bottom here I'm turning around, and then I'm coming up and I'm touching the x-axis, and then I'm going down again to infinity. So I know that between 0 and 20 I've kind of covered all of the real action-packed parts of that function. And my velocity function, well, because it's a derivative of a cubic function, it's going to be a quadratic function, and I can see that I've covered my zeros. It'd be nice if I could see my maximums and minimums down here, and I'll do that in a minute. But for x-axis purposes, this 0 to 20 is okay. And my third derivative, acceleration, is linear. So really all I'm concerned about is where it crosses the x-axis, maybe where it crosses the y-axis. So how am I going to set my y values now so I can get a good look at this graph? Well, I'm going to zoom out. And I'm going to zoom out until I can see places where these graphs turn around. And I can see, well, it looks like this quadratic graph turns around at about, it looks like about, 40. And then the cubic graph, that's the orange one, that's my position function, looks like that turns around at like around -200. So I'm going to use those as my settings. I'm going to go here, I'm going to say my y-axis, let's take it up to +50. Negative, I start with the negative, so I'm going to go to like, -250. Let's get rid of that 0, that'd be painful. And positive, I'll go up to like 80 or something, that's above the 50. Maybe I'll go to 60. Okay, now let's look at my graph. It still looks kind of tight. My x-axis changed. Why did my x-axis change? I don't know why. I'm going to change that back down here to, come on now, -1. It changed when I zoomed out. -1 to 20.
Okay, so now I have a pretty nice looking graph. I can see all the action. It's not particularly well proportioned, but that's okay for me. I can see what all my key points are here. And now I'm going to do something else. I'm going to check my derivatives. So I'm just going to set up a dummy function. I'm going to call it g of t, because t is the value I'm using for my x-axis. And I'm going to set it equal to, well, I'll go over here to functions, and I'm going to go the derivative of, now it's not derivative with respect to x, it's the derivative with respect to t, because my axis is a t-axis, not an x-axis. And I'm going to say, well, what's the derivative of s of t? And I'm going to erase the a, and I'm going to erase the s, and I see I only have one graph. Oh, they're both blue. I got to change the color. If I need to change the color, I go over here to this settings button, and I can click on the color, and let's change it to purple. Okay, and I go done. So I see a purple graph right there, purple probably, and a blue graph and a purple graph, and they look identical. Those are, so I've kind of confirmed that my velocity function is in fact the derivative of my position function. And now to see whether my acceleration function is correct, I'm just going to change this s right here to a v, and I'm going to look at, that's the derivative of my velocity function, and let's see if it's the same as my acceleration function. Green, purple, green, purple, they look the same. So I've now confirmed using graphs and Desmos that my derivatives that I calculated were correct. So let's get rid of that, don't need that anymore.
And we'll go back to the problem and find out, when does the particle change direction? Well, the particle changes direction possibly when velocity is equal to 0. Not always. If velocity equals 0, it can be a pause. It doesn't have to be a change in direction, but we'll find out. And certainly velocity has to be equal to 0 if it's going to change direction. So, where does my velocity function equal 0? Well, this is kind of a big number here. I could use the quadratic formula, but let's see if it's factorable. So I'm going to use the surefire method. I'm going to multiply -3 times -121, and I get positive 363. And I need to find out, are there any factors of 363 that when I add them together are going to give me 44? And I just do this in a very boring but systematic way. And I start looking for factors of 363. Well, of course, I have 1 and 363, and that's not going to work. And no multiple of 2 is going to work because it's an odd number. 3 is going to work, so I have 3 and 121. That's not going to get me 44. 6, let's see. 4 is going to work. 5 is not going to work. 6 is not going to work. 7 is not going to work. 8 is not going to work. 9. Does 9 work? Nope, 9 doesn't work. 10 doesn't work. 11. Let's try 11. If I divide 11 into here, I get 33. And there's my 44. I can see it. So if I have positive 11 and positive 33, those are going to multiply to get me positive 363, and they will add together to get me 44. So I'm going to change this to -3t plus 11t plus 33t minus 121 equals 0. All I've done is I've just changed my 44t into 11t minus 33t. And now I'm going to group. So I'm going to group that, and I'm going to group that. And of course, I can't forget my squared over here. And in this first group, all I can pull out is a negative t. So I'm going to take out negative t, and I'll wind up with 3t minus 11 plus Well, over here, it looks like I can pull out an 11. So I take out an 11, and I get 3t minus 11. That's good. It better work that way. Equals 0. So now I have 3t minus 11 times negative t plus 11 equals 0. And I get t equals 11 thirds and t equals 11. So both of those are times when my velocity is equal to 0. So the question is asking, well, am I changing directions? I'm going to find that out. And then I'm going to find out when is the particle moving left and when is the particle moving right. And I'm going to do that by putting together a number line. I'm starting at 0 seconds and I'm going to infinity seconds. So I have one time at 11 thirds and another time at 11. And they don't have to be to scale, it's really just conceptual here. And what I want to find out is where is my velocity positive and where is my velocity negative. Because if I change from positive to negative, I change directions. If I go at 11 thirds or 11 and I go from positive to positive, it means I just paused. So let's use the calculator to help us with this. I've entered my three functions, my position, velocity, and acceleration functions into my calculator. And I want to know about velocity. Well, is it positive or negative between 0 and 11 thirds? Well, so I'm going to go to my main screen, and then I'm going to go alpha F4, and my velocity function was y2. So I'm going to look for a y2, and I'm going to evaluate it for some number between 0 and 11 thirds. So let's just evaluate it for 1. And I hit enter, and I find out it is negative in this interval right there. And it has to be, there can't be any other spot between 0 and 11 thirds where it's positive, because if it was, then I would have crossed the x-axis. And I know I only crossed the x-axis right here at 11 thirds. There's no other place between 0 and 11 thirds where I do so. Well, let's evaluate velocity for some number between 11 thirds and 11. So let's go alpha F4. It's my y2, my velocity function. Let's evaluate it for 10. And I find out that's positive. So it's positive here, every place between 11 thirds and 11. And let's check our last interval, which is above 11, alpha F4, y2, parentheses, let's check it for 12. And it's negative 25. So I'm going negative velocity, positive velocity, negative velocity. And I could have seen the exact same thing on my Desmos graph. I've now got my velocity graph up there, and I can see that, well, here I am at 11 thirds, which is like 3 2/3 right there. That's 3 2/3. And here I am over here at 11. Those are my zeros. My velocity is going from negative down here to positive between there, and then my velocity again changes to negative. So I'm confirming it every which way, and I'm feeling pretty good about this problem so far. So I found out when the particle, the times when it changes directions. That's the 11 thirds at 11. And I've also found out when it's moving left and when it's moving right, because that is when I'm going in a negative direction, I'm going left, just like it was on a number line. When I'm going in a positive direction, I'm going right. And when I'm going in a negative direction again, I'm going left. So if I was to answer that using interval notation, I would say I'm going left from 0 to 11 thirds, union 11 to infinity. And I'm going right from 11 thirds to 11. Now I'm putting it as parentheses because I think when I'm actually right there where my velocity is 0, I'm going neither left nor right. I'm changing direction, so I'm neither going left nor right. That's why I use parentheses instead of brackets. Well, so now I want to find when is the particle slowing down and when is the particle speeding up. And in order to do that, I need to find out when is the acceleration equal to 0. Because remember, when acceleration is in the same direction as my velocity, I'm speeding up. When acceleration is in the opposite direction of my velocity, I'm slowing down. So here's my acceleration function. I think I'll set it equal to 0. I'll get negative 6t is equal to negative 44. I get t is equal to 44 over 6, which is the same thing as 22 thirds. So that is when my acceleration hits 0. So I'm going to do the same thing with the number line. I'm going to go, here's 0, and here is infinity. And, well, let's make this number line look similar to that number line. Now, we'll come back to that number line. Here is, let's call this 22 thirds. And, well, when is acceleration positive and when is it negative? I could really do this one, I should be able to do this one in my head, but I'm going to use the calculator anyways. Acceleration is my y3, alpha f4, y3. Let's evaluate y3 for the number 1. And I find out, well, acceleration is positive in this direction, between 0 and 22 thirds. And since it's a linear function, and that's a 0, I know it's going to be negative above 22 thirds. But let's just do it just to be happy with ourselves. Here's y3, and let's evaluate it for, I don't know, 23 thirds. 23 divided by 3. 1 little over. And in fact, it's negative. No surprise, if I looked at it on the Desmos graph, I'd see the same thing. Let's look at the acceleration. Here's our 22 thirds, and you can see it goes from positive acceleration, hits that 0 right there at 7 1/3, and then it goes to be negative acceleration. So now let's take a look at these number lines together. And again, they don't have to be to scale, but they do have to be, the numbers have to be in the right position. So I have from 0, so this one here was my velocity. And this one here was my acceleration. So I'm going from 0 to infinity, and here's 11, and here is 22 thirds, and here is 11 thirds. So I have 4 intervals. 1, 2, 3, 4 intervals that I'm concerned about. And what I'm going to do is I'm going to say, well, let's look at both acceleration and velocity. So here's velocity, here's acceleration. So let's look at something so I can see them both. Between 0 and 11 thirds, well, my acceleration is negative, and my velocity is positive. Between 11 thirds and 22 thirds, my acceleration is positive, and my velocity is also still positive. Wait, stop. We're going to erase that. I don't want to redo this whole video here. I mixed up my graphs. This one is the acceleration. This one is the velocity. I copied it. This is acceleration. This is velocity. So let's go back again and just relook at our intervals. between 0 and 11/3, my velocity is moving left, it is negative. My acceleration, however, is positive. Between 11/3 and 22/3, my velocity is positive. My acceleration is also positive. Between 22/3 and 11, my acceleration has changed to negative. My acceleration has changed to negative. Make sure you put it in the right spot. And my velocity is positive. And then from 11 seconds onward, my velocity is negative, and my acceleration is also negative. So, in this case here, from 0 to 11/3, let's make a nice line there, I'm slowing down. From 11/3 to 22/3, I'm speeding up. From 22/3 to 11, I'm slowing down. And from 11 onward, I'm speeding up. So if I want to write that in interval notation, I'm slowing from 0 to 11/3, and from 22/3 to 11, and I'm speeding up come back. From 11/3 to 22/3, and from 11 to infinity. I've answered all the questions now that they are asking me in this problem.